In this question, we are given that a mass of 10 kg is measured with an instrument and the readings are normally distributed with respect to the mean of 10 kg, and we are given the value of this integral equals to 0.6, and also that 60% of the readings are found to be within 0.05 kg from the mean. Then we want to find what is the standard deviation of our measurements of the mass. So first note that the probability density function of standard normal random variable capital Z is given as Fz equals to 1 upon root 2 pi e to the power minus z squared by 2, and the z lies from minus infinity to plus infinity. And here this integral is nothing but twice of the area under standard normal density function from 0 to 0.84, or we can also say this is the area under the standard normal density function from minus 0.84 to plus 0.84, and we will use this value to find standard deviation of our mass measurement. And we are also given that the measurements of the mass are normally distributed random variables, and let's denote that random variable by capital X. Then capital X will be normal random variable with mean mu equals to 10 kg and standard deviation sigma unknown, and we are given that 60% of the readings are found to be within 0.5 kg of the mean. That means the probability that our random variable x will lie between 10 minus 0.05 and 10 plus 0.05 kg is 0.6, or this I can simplify as probability of 9.95 less than equals to capital X less than equals to 10.05 is equals to 0.6. Now to find standard deviation and this probability, I will transform this normal random variable into standard normal random variable, and that I do by subtracting the mean from all these and dividing all these by standard deviation. And here note that the inequality remains unchanged if we subtract something from both sides of the inequality or divide both sides of inequality by a positive number. So subtract the mean and divide by standard deviation. So I get 9.95 minus 10 divided by sigma less than equals to x minus 10 divided by sigma less than equals to 10.05 minus 10 divided by sigma is equals to 0.6. This implies probability of minus 0.05 divided by sigma less than equals to, now this x minus 10 upon sigma becomes standard normal random variable. I can denote that by capital Z less than equals to 0.05 divided by sigma. This is equals to 0.6. This implies, and we know that standard normal random variable is symmetric about its mean, which is 0 and which lies at origin. So minus 0.05 upon sigma less than equals to z less than equals to 0.05 upon sigma can be written as 2 probability of 0 less than equals to z less than equals to 0.05 upon sigma, and this is equals to 0.6, and this probability I can write as integral from 0 to 0.05 upon sigma 1 upon root 2 pi e to the power minus z square by 2 dz, and that is equals to 0.6, and this is also 2 upon root 2 pi integral 0 to 0.05 divided by sigma e to the power minus z square by 2 dz, that is equals to 0.6. And here note that this integral is same as this integral here, where in this case the dummy variable is eta instead of z. So this upper limit of 0.84 will be equals to 0.05 upon sigma. So this implies 0.05 upon sigma is equals to 0.84. So this gives me sigma equals to 0.05 upon 0.84, and that is equals to 0.0595, and that is approximately equals to 0.06. So our option C is correct.